because this document came from the National Academy, it's not just affecting what achievement students. It has a national status in affecting the APT, the professional societies, SMITI. It has an impact. If you want teachers to teach these practices, well, they better have experienced them somewhere, which means the science courses that they took in college had better have engaged in this kind of thinking about how science gets learned and taught. And so this influence of this document, long range, is more than just on K-12. Because in order for K-12 to function in this way, you have to think about what higher education has to do in order to produce teachers who are ready to function in this way. And as somebody mentioned earlier, you have to think about, given the teachers we have today, what support do they need to, particularly if you're thinking about the K-8 course here, what support the elementary teachers need to be able to teach science with this perspective? Or to teach science at all. In fact, in too many classes today, too many elementary schools today, science doesn't even start until maybe fourth grade. And then very little. So thinking about what directions are being pointed here, there's many pieces to this puzzle, and the framework is supposed to help guide us in all those directions. I hope it can. I'm optimistic that it is beginning to, but we will see. Thank you.
As you can see, we're tremendously fortunate to have somebody so engaged, so talented in leading and producing such a great lever for national change here. Take a quick question or two and then move on to our last speaker.
Why was the epistemic characteristics of the nature of science de-emphasized in the framework?
Not deliberately. The idea is that rather than teach that, engaging students in doing science actually helps them learn that better. That's a theory. Whether it's true or not, we don't know until we try. But it's partly a matter of trying to figure out how all the pieces fit together. And we had a little bit of it in the July draft that went out, and it didn't make it through to the final draft because it just didn't fit. So it's odd, and it wasn't a decision, oh, that's not important. It wasn't that at all. But it was rather, the nature of science is learned by doing science and at the same time reflecting on what you're doing. And since we're talking about reflective practice across everything, I think that's where that piece lives. You may disagree.
Well,
and we'll have an opportunity for collective discussion about this at the end, if we get there, so thank you. Last question.
I was wondering about testing, standardized testing, because I found that I was heavily influenced in the classroom by my fellow physics teachers.
That's why assessment is on the list, right?
Okay, and then the assessment I was hoping would cover the first two dimensions, whereas currently it only seems to cover the core concepts.
Right, and that depends on the standards, also maintaining the three-dimensional structure. But even if the standards are three-dimensional, how do you make the assessments three-dimensional? I think that's actually one of the biggest challenges. And it's sort of the field that has maybe the furthest to go to get to this model. And so this is the problem. How can you ask teachers to change when the assessments that their students and even they are being judged by haven't changed? I understand the magnitude of that problem. And all I can say is we're pushing on it. It's one of the many fronts where lots of work needs to be done.
And we'll be the ones doing that. So please join me in congratulating and thanking Helen. Thank you. So our final speaker then actually bridges it, takes up the mantle and the charge that Helen had just alluded to, which is to actually respond, to engage, to provide feedback and demonstrate how individuals can act and participate in change systems. Pat Heller's on the faculty of Curriculum and Instruction at the University of Minnesota and a founding member of the Physics Education Research Group there. She's been at the forefront of physics education research for most of her career, conducting leading research on instructional beliefs, cooperative groups, and she's been really engaged in improving physics education at all levels. She's created curricula for elementary, middle, college students, teaching assistants, and even the old dogs, college professors. She's worked on science teaching licensure standards for Minnesota's Board of Teaching, and was a consultant on the AAAS science standards, benchmarks for science literacy, and a committee member for the College Board Science Standards for College Success. In fact, Heller's name is so present in the physics education world that you would think that there are two of them. So please join me in welcoming Professor Heller to speak to us.
What I'm going to offer today is more informational and is about the AAPT involvement in this development of the next generation of science standards. I'm changing my agenda a little bit. I'm going to concentrate mostly on giving some information about who were the key players in the development of the framework and the Common Core standards, and how the AAPT has responded throughout this development process, and will continue to respond, I hope. I'm going to skip this. Probably the most important organizations involved in initiating Common Core standards was the Council of Chief State School Officers and the National Governors Association. So that's where this is coming from. These are the big organizations that were involved. We already have 45 of the 50 states have adopted the Common Core English standards and the Common Core mathematics standards. So it's a big movement. The Common Core science standards started as a collaboration between, or partnership, if you like, between 4 organizations: the National Academy of Science, the National Science Teachers Association, the American Association of Physics Teachers, and this corporation called Achieve. And the development of the standards was thought to be happening in 2 phases. The first phase Helen has talked about, which is development of the framework for the K-12 science education, for K-12 science education. And this development was also, I think, influenced in part by the College Board AP, in terms of the physics, the College Board AP revisions, which are being talked about in this meeting, as well as the Science College Board Standards for College Success, which came previous to the development of the framework. Helen already showed this. This is just a glance at the people who were on the physical science design team. And there's a physics, chemistry professor, people in chemistry education, and 2 AAPT members, Sophia Gershman and Arthur Eisencraft, who's best known for his development of active physics and active chemistry for high school teaching. The Achieve, then, this corporation called Achieve, is supposed to take the framework and develop standards based on this framework. I'm not quite sure what that means, and I don't think we'll know what it means until we see them. But you might ask, who is Achieve? I had never heard of them before. So I looked, this is what they say about themselves, that they're a nonprofit education reform organization that was created by the nation's governors and corporate leaders, who are all governors and corporate leaders are all on the board of Achieve. And their purpose is to raise academic standards and graduation requirements, improve assessments, and improve or strengthen accountability. And there are several projects that Achieve has already got going that in these areas. Who is it at who are the staff members at a chief that are responsible for leading this, the creation of the national standards. There are two people.